Welcome to Let's Talk Micro. Hello, everyone. Welcome to another episode of Let's Talk Micro. Like always, I hope you had a great week. Before we get started, remember that Let's Talk Micro it's available on Apple Podcasts, Spotify, Google Podcasts, Stitcher, TuneIn Radio, Overcast, Amazon Music, Pandora, whatever you listen to your podcast, you can find Let's Talk Micro. I am also on Instagram as Let's Talk Micro, no apostrophe, and on Twitter as Let's Talk Micro 1. So go ahead and follow. I always like to post updates on when the next episode is coming in. I like to post pictures of organisms. On the last episode, I went over Staphylococcus aureus, right? This is a very important organism. Like I mentioned, one of the most commonly encountered organisms in clinical microbiology. So it is a gram-positive cocci in clusters that is catalase positive and coagulase positive. Now, I'm going to talk more today about catalase and coagulase, but go ahead and listen to episode 6 of this podcast. I talked about it. So go back, and if you haven't listened to the previous episode, go ahead and do so, because this is going like in a series. So go ahead and listen to that, and then come back and listen to this one. That way it can all be fresh. It is a gram-positive cocci in clusters, catalase positive, coagulase positive. It is a facultative anaerobe. I talked about that this organism is typically a colonizer, and we sometimes carry it in our nares. I talked about 3 types of carriers associated with colonization. We have persistent, intermittent, and non-carriers. Like I mentioned, if you haven't listened to the previous episode, go ahead and go back and do so. I talked about what these types of carriers mean regarding the strains of Staph aureus. So it's good to go back and refresh. Infections with Staphylococcus aureus, they're typically acquired when the organism gains access to a sterile site. And this can be via trauma, such as an injury, surgery. I also talked about the different types of toxins and virulence factors. You have protein A, you have alpha toxin, toxic shock syndrome, and scalded skin syndrome. So like I mentioned, this is a very serious organism, and I talked about how it can be transmitted from person to person and via fomites. So this makes it very serious in healthcare settings. This is why hand hygiene is very important. Staphylococcus aureus causes nosocomial infections, which are hospital-acquired infections. If the organism is resistant to methicillin or oxacillin, which is a synthetic form of penicillin, the organism is called MRSA, methicillin-resistant Staphylococcus aureus. With this kind of resistance, it is considered resistant to beta-lactam agents, such as carbapenems, cephalosporins. The exception is ceftazolline. Ceftazolline, which is the brand name is Teflaro. Detecting MRSA is very important because the spread needs to be stopped and the patient needs to be treated. I mentioned in the previous episode that there are some ways to screen for it via chrome agar, which when the organism grows on it, if it is MRSA, it will produce a specific color based on what the manufacturer has. But on this episode, we're going to start working it up when you have it from your standard culture setup, meaning your blood, your chocolate, your mac. Typically most cultures, like I mentioned before, they have like a wound culture or a respiratory culture. Your standard setup is blood, chocolate, and mac, and sometimes you can have PEA. How do we identify it in the lab? Well, we start with colony morphology. Staph aureus colonies are large and flat. They are also typically beta hemolytic, and they mostly have a yellow pigment, which you can actually greatly appreciate on chocolate agar. So keep this in mind about the hemolysis, because this is part of presumptively identifying it. which I will talk more about in a little bit. So we perform biochemicals. So we are screening our plates. When our culture is set up, we look at it 18 to 24 hours later. So we see these large flat colonies. So we do biochemicals. And I talked about catalase coagulase, and I mentioned episode 6. So go ahead if you need to go review it. Go and take a listen. Have a listen. So catalase is typically used for gram-positive cocci and rods. So what is catalase? It is an enzyme that catalyzes the release of water and oxygen from hydrogen peroxide. So how do we perform the test? Well, you add a drop of hydrogen peroxide, you place it on a slide, and then you add a colony and you apply the drop. There's also where you can actually apply the colonies to the slide and then add the drop. A positive reaction is bubbles, right? As that oxygen is released, you're going to see bubbles. So that's a positive reaction. But keep in mind, and I mentioned this, but I really like to emphasize, especially with students and younger techs, brand new techs, a positive reaction is a quick and immediate reaction. And I'd like to mention this because Enterococcus faecalis can have what they call like a delayed, weak positive reaction, which is a negative. This means that you apply the colony and maybe a second or so after, you see some tiny bubbles. And this is negative. So this tends to throw students down the wrong way because they have this result. They think it's positive. So when they're working in a lab, having an exam of some kind, they start working it up as it's a staph. And that is wrong. But like I mentioned before also, you have to keep in mind the colony morphology. So this is why I like to tell students that when you work in these organisms, take advantage of technology and take pictures. That way as you study, you remember. So even if you have an Enterococcus and you have this reaction, based on your pictures and what you've seen, you say, wait, I'm having a positive reaction, but this doesn't look like a staph. So you need to always keep in mind the colony morphology. But just remember, if you get this weak reaction, it's considered a negative. So this is very important for you students, that if you're working on an unknown, don't end up identifying it or presumptively identifying a staph because you get this catalase positive reaction. So it's a weak delay reaction, which is considered a negative. So a positive reaction is bubbles, real quick and strong, and then no bubbles is a negative reaction. So this is a very typical, always a gram stain, gram positive, though that's always very helpful, but very typical workup, catalase, staph versus strep. Staph is positive, strep is negative. So then the next test will be a coagulase. Staph aureus produces an enzyme, coagulase, which binds plasma fibrinogen, causing the plasma to clot. And there are some variations of coagulase. There is the bound coagulase or clumping factor. This is detected using a rapid slide test. And there is also the free or tube coagulase. But this takes 4 hours. This is done if a suspected Staph aureus, a colony that you're suspecting it to be Staph aureus, it's negative for the bound coagulase test. However, I will say maybe here in the States or most of the labs that I have worked, at least, we use a test that is much faster. You get a very rapid result, which is within a minute, 60 seconds. So this is called the Remel-Bacti-Staph test. This is a latex agglutination test recommended for the detection of clumping factor and protein A. Right, you heard about protein A. So it is used to distinguish Staph aureus from other species of staph. It is definitely a rapid test, and I like to say it again, it means that you will get a result relatively quick. In this case, 60 seconds. Very easy test. So what does it have? What are the components? Well, it has a latex. This is your reagent. It is a protein-coated latex particles that are capable of detecting both clumping factor and protein A. This is another very simple test. You add a drop of the latex to the testing area. Then you pick 2 to 5 colonies from your plate and apply them to the dry area of the test circle. So when I'm talking about, if you text that work with it, or maybe students in clinicals, you might have seen it. So the test card has 6 circles. So you can test 6 different colonies, 6 different organisms. On one of the circles, you will add the latex. And then on a dry area, using a wooden stick, you will pick your 2 to 5 colonies. And then start on the dry area. And then start mixing them with your latex. After this, you can rotate it. And this can be done via 2 methods. You can rotate it using, just holding it with your hands in a circular motion for 60 seconds. You can also use a rotator if you need to. This is also good with the strep agglutination test. But the package insert says that do not set the speed higher than 125 RPMs. So do not set it higher than 125 RPMs. But you can use a mechanical rotator. So after this, you examine it after the 60 seconds. And then if you see agglutination with the loss of the black background, this is considered a positive test. If there is little to no agglutination with no loss of the black background, then this is a negative. So definitely when you have like on your Staph aureus, which is positive, when you rotate it, you will see this nice clumping. And then as the background being lost, it means that, so it's not murky anymore, it becomes like clear. So all you see is your clumping. But if it's negative, you might see sometimes, little clumps, but then the background is still murky. It hasn't cleared. So that's what it means. A positive versus a negative result. Positive, clear background with clumping, little to no agglutination, murky background, it's considered a negative test. Just because it's positive doesn't mean that you're going to go ahead and say, oh, this is Staph aureus. You have to keep in mind that if it's beta hemolytic, and the morphology, it looks like it's beta hemolytic, and this is positive for this test, you can presumptively ID it as Staph aureus. Meaning there is no need to do any other method of ID. Like you don't need to put it on the VITEC. You don't need to do MALDI-TOF. You can call it Staph aureus. If the hemolysis is weak, if the organism is non-hemolytic and you get a positive result, you need to put it on the MALDI-TOF, MS, any other method that your lab has to identify it, other than this. So you definitely have organisms that can cause false positive reactions, such as Staphylococcus schliferi, Staphylococcus saprophyticus, Staphylococcus lugdunensis. They can cause false positive reactions. And other coagulase positive staph will be positive for this test, which that's a conversation for another day. For now, let's talk about Staph aureus versus coagulase negative staph. Like I said, if you get a positive result but weak hemolysis, no hemolysis, you need to perform another method of ID. The same is the opposite. Sometimes you can get, maybe the kit might not work properly. You can get a negative reaction. So in this case, that it's a Staph aureus. It looks like beautiful, large, flat, beta hemolytic, yellowish colonies, and you're looking at them and say, it's Staph aureus, but you keep getting a negative test. You need to go ahead and perform another method of ID, like VITEC or MALDI-TOF. With presumptive identifications, which are organisms that you don't need to do another method based on biochemicals and certain morphologies and characteristics. You can go ahead and call them. You can identify them like this, like Staph aureus, E. coli, lactose fermenter, indole positive, lactose fermenter flat. So if they meet this certain criteria, you can identify them just based on that. No need to do any other instrument type of identification. That's what a presumptive ID is. So anything that deviates from that, you need to perform an ID. But if the criteria is met, you can go ahead and call it Staph aureus. Now that we know how to perform the test, a good question that you might be thinking is, does it matter which media we use? I mean, you mentioned, Louis, that you have that your standard setup when you're working in these benches, it's a blood plate, chocolate, McConkey, PEA. Doesn't matter which one you use. Well, it's a gram-positive cocci, right? So it's not going to grow McConkey. However, out of the blood, chocolate, and PEA, does it matter which one you use? Well, the answer is yes. The package insert has a complete list of the media that you can use. But definitely among these is blood agar, which you typically might see it, with like trypticase soy agar with 5% sheep's blood. You can use CNA agar. You can use mannitol salt agar. I have seen, like in my facilities, we use PEA. But if you're going to use another media, you need to perform a validation. And that's another, you need to run an X amount of samples, make sure that, compare them with your typical media. And based on the results, you're able to use another type of agar. So it will need to be validated. Once we identify this organism, right, based on the seriousness of it, so significant, nosocomial infections, you want to make sure that patients that if they're having surgery, they don't have it, they can get treated. So we want to know if this is an MRSA, right? You tend to get these chromogenic agars that I will be talking about in the next episode, where it produces that color. So this is very typical for the patients that are going on surgeries. They get that screening. Typically, this chrome agar is for nasal sources. So you want to know if it's an MRSA. But like I mentioned before, with your catalyst and coagulus, right, you're working on the bench. You're getting it from a regular culture. It's not a screening. It's just, there's an injury of some sort. There's a wound. So you're isolating it from your standard setup. So how can you identify it as MRSA without putting it in one of these chromogenic agar plates? Well, you can definitely, once you do susceptibility, you know what it is. It comes back resistant to oxygen. It is considered an MRSA. But before that, how can you identify it as MRSA outside of your PCR and your chromogenic agar? There is a test that we use for this, which is really good, and I'll be talking about it in a minute. We also want to know if the organism is MRSA, so like in the case that we are referring a culture. So let me talk about this in clinical micro. Typically, if you have two cultures or more, from the same patient, if they have the same organism, you can refer the susceptibility portion from one culture to another, as long as they are the same source, and depending on the facility, if they are within like 2 or 3 days apart. So, meaning, for example, you have a patient that has a right leg wound culture. Patient goes to the doctor on a Monday. They swab the area, and then the culture yields, Staphylococcus aureus. You perform the susceptibilities, and it comes back as an MRSA, methicillin-resistant Staphylococcus aureus. Then on Wednesday of the same week, the patient has another culture from that same wound, and it yields Staph aureus. So do you need to perform susceptibilities again or not? Well, in order to not perform them, if it meets the criteria for referring the culture, you need to determine if this Staph aureus is a MRSA, because the first one was. Remember that we carry Staph aureus in our skin, and then it doesn't cause any trouble until it gains access to a sterile site. So this test is very helpful for that, because if we perform it and we determine that it's an MRSA, then we can go ahead and refer that susceptibility to the other one. So this test that I'm talking about is the Abbott Clearview PBP2A-SA culture colony test. And I'm getting a little technical here. This is a qualitative in vitro immunochromatographic assay for the rapid detection of penicillin binding protein 2A. This protein confers resistance to methicillin. So this test is used, it has a highly sensitive recombinant monoclonal antibody fragments that are used to detect this protein from bacterial isolates. It is a test strip that contains the monoclonal antibody fragments and a control protein. It comes with two reagents. You have reagent 1 and reagent 2. And it also comes with an assay tube where you're going to place your strip. You add 2 drops of reagent 1 to your tube. This reagent is blue in color. Then you add a heavy inoculum of your isolated colonies. And then you add 2 drops of reagent 2. At this point, once you add the reagent 2, it turns clear. It changes from blue to clear. And the package insert states to briefly vortex it. Once you have done this, you insert the test strip in the tube and you wait 5 minutes. The strip has a test line and a control line. A negative result is a pink-purple control line that appears on the top half of the strip. A positive result is a pink-purple control line and a pink-purple sample line that appears on the bottom half of the strip. So regardless of it's a negative or positive, you need that negative control line. And this is typical of this type of test. It always has a control line that it needs to be present for the test to be considered valid. So if you have both lines, the control line and the test line, then it is a positive result. Now another question, because sometimes I have seen this, what about if it's maybe a faint line? Is this considered a positive, a negative? The answer is it's a positive. Any line intensity for the test line is considered a positive result. And like I mentioned, if a control line is not present, the test is considered invalid and the test needs to be repeated. So having a positive result, you can refer these cultures as long as it's the same source. And now this can vary, from facility to facility. Sometimes, if you have a culture from the left arm and the right arm, you can refer them like this. This is very useful in blood cultures, because with blood cultures, you typically collect, 2 to 3 sets. So if they're all come positive for Staph aureus, if you do susceptibilities on one, let's say that they collect 2 sets, and then 2 days later they collect 2 more sets, and all 4 are positive for Staph aureus, then you can go ahead and do susceptibilities on one set, refer to the other, and then the 2 days after that, the culture from 2 days after, you can perform this test, make sure that they are MRSA or Staph aureus, because of course if the original was negative and then the second one is negative, then you can refer them as well. So it is a very useful test. And sometimes, some facilities you can proceed with you detect your Staph aureus, you perform susceptibilities, then the next day you report as MRSA. But sometimes other facilities, doctors want to know right away if it's MRSA as soon as you have a Staph aureus on any of your cultures. So it is definitely a very useful test. So not only it is useful for the detection of MRSA, but at the same time, like I mentioned, if the initial culture from that source was susceptible to oxacillin, and then that second culture is susceptible as well, you don't need to perform susceptibilities on that second culture. And this always is going to vary with your facility. Catalase coagulase, and then you can find out if it's MRSA before performing susceptibilities on it. As far as for this test, which agar to use, it's on the package insert, but blood agar is definitely one of them. Not PEA. If you get it from PEA, you should sub it to a blood agar plate and then perform this test. So in addition, like I mentioned, you also have these chromogenic agar, which produce a specific color, which I will be talking about on the next episode. And that, my dear audience, it's the end of this episode. I hope you enjoyed listening about catalase, coagulase, penicillin binding protein, and Staph aureus. Like always, I enjoy talking about it to you. I cannot repeat this enough. Continue bringing that passion to what you do. This is such an amazing job that we do. We help the patients so much. So it is important that we continue educating ourselves and bringing passion to it, because it will make it so much better. Like always, stay motivated, stay safe, and of course, continue talking micro. Until the next time, bye.